Hello, my dear super champions. How are you all doing? All good? So, welcome to this amazing platform of Physics Wallah. And this Ignite batch is specially for those students who want to study in pure English. Your Ignite batch. So, today we are going to master acid, bases, and salts in one shot. That's very much interesting. So, let me know how's the Josh. Hi? Yes, of course. So, before starting this lecture, I will like to give you some examination tips. To score more than 95% or 95 marks in your any subject. So what is that? Get ready with your pens. What is that, ma'am? So my dear student, P stands for PYQ. Your previous year exams, previous year question, they give you the idea, the pattern of the examination so that you can get the higher grip on your knowledge. Next is your exemplar, very much important. Don't try to skip it. Next is your NCERT, the holy book. Read each line and your sample paper. If your pens are ready, you are ready to rock. So, without further ado, we can start with the chapter. Today we are going to cover whole chapter. So in this chapter we are going to deal with acids, bases and salts. So the very first thing comes in mind when we are talking about acid and bases. Are these things are working in labs only, or are we using them? Of course, we are using acid as well as bases in our daily life. So you see, your carbonic acid, your soft drinks contains carbonic acid. Then we have your car batteries contains sulfuric acid. Your tartaric acid is wine manufacturing. Nitric acid is used in the fertilizer. You can check all these uses. For digestion, hydrochloric acid is way much important. Now, in the medical field, pharmaceutical field, we are using aspirin. That is what? That is a salicylic acid coming from acid derivatives. Now, acetic acid, citric acids, and the acid used in the labs, they can be the mineral acid, the strong acids. Now, talking about bases, we have the soaps, right? The cleansing agents, detergents, baking soda. If you want to make your food crispy, fluffy, you can add baking soda. Now the cement, fertilizers are very important. Yes or no? Right? Then treating acidity, your antacids are made up of bases, mild bases. So we consume them in day-to-day life and they are not that much harmful. So what is the exact meaning of acid and what is the exact meaning of bases? Before getting into that, let's have one activity. Suppose your teacher gave you 3 test tubes, right? And in one test tube, it's basic solution. In 2 test tube, it is acidic solution. And suppose in the third solution, it is neutral in nature. Now, you are provided with red litmus. Let me check. You are given with the red litmus. So, how will you identify the contents of each test tube? So, that's the question. How you are going to indicate whether the solution is acidic, basic and neutral. So, using your litmus is a natural indicator derived from lichens. Yes or no? So, red litmus remains red in the case of acidic solution, right? We will be covering this topic later also, but yes, red litmus turn into blue in the basic solution and it remains red also in the case of neutral. Yes or no? So we have started the lecture with the activities. We have to do many activities during the lecture. So acids are those which are sour tasting. Tasting means previously people used to taste it, right? They discovered that everything which has a sour taste can be acidic, right? So basically it comes from the Latin term acidus, which means sour. Sour means you are tasting it. But is it possible that we can taste all the acids? No, it's not the clear definition. So with respect to time, we got another definitions like Arrhenius, Bronsted-Lowry and Lewis acid. They define acids in their terms. More prominent definition in this chapter is going to be Arrhenius acid or Arrhenius base definition. So what did Arrhenius say? So basically acid is something which contains hydrogen ions, right? And when dissolved into water, acid when dissolved into water, that means it's the aqueous solution. Yes or no? Aqueous solution of acid which contain H positive ions. Axis of H positive ion. I would like to write axis of H positive ion. That is what we call acid. Now, this is about Arrhenius. Prominently in this chapter, we are going to deal with Arrhenius definition for acid, Arrhenius definition for bases. I repeated this line because it's very much important. Now, according to Bronsted-Lowry, a proton donor is said to be acidic, while according to Lewis, you can say electron acceptor or the electron poor species is said to be what? Acid. In the higher classes, we are going to deal with these two definitions also. Now, coming to the next part, which is base. So, we are doing what? We are actually parallelly understanding about acid, then base. You can clearly distinguish between acid and a base. So, base is bitter tasting. As you know, tasting something is not a clear definition. It can be hazardous, yes or no, right? So bases are bitter and slippery in touch. You see Arrhenius base, Bronsted-Lowry base and the Lewis base. We have again three definitions. Prominent is Arrhenius definition for base. So bacha, again you can write when a base is dissolved in water, it will form basic solution, or you can say the aqueous solution of the base, which contain axis of OH negative ion, right? Axis of OH negative ion indicates that the substance is basic in nature. Now, Bronsted-Lowry said exactly opposite to the acid, which is a proton acceptor. Lewis said bases are electron donors unlike acids. So are we good with the definition, because it's going to help you out. Now, alkalis. What are alkalis? Suppose there are many bases. Base, base, base and many more bases, right? So suppose out of these, this base can dissolve in water. So I would like to call it alkali. Simple, right? So there are n number of bases, but the particular base which can dissolve in water, which can be soluble in water, we call that alkali, right? So most of the bases are insoluble. For example, you have copper hydroxide. That's a base, but it is insoluble in water, cannot dissolve in water. However, some bases are soluble in water like NaOH, KOH, etc. Right? So we call them alkali. Are we good with this? Great. So soluble base can be called as alkali. So don't get afraid of alkali. What are these? I am not understanding the difference between base and alkali. All are bases having axis of OH negative ions. But we call alkali to those bases which are soluble in water. Great. Okay. Now let's discuss the uses of alkali. Right? Alkali are the mild bases. So basically, sodium hydroxide, commonly known as caustic soda, is used for making soap, washing powder, drain cleaner, for cleaning purpose. Right? In short, you can write it, in cleaning purpose we use caustic soda. Now we have potassium hydroxide, commonly known as caustic potash, which is used in making paint remover dyes for the fabrics. Right? These are the uses. We use them into the industries, into the daily life. Calcium hydroxide, or we call it slaked lime. In chapter 1, chemical reaction and equation, we prominently understood the function of calcium hydroxide. So basically, whether it is basic in nature, it will reduce the acidity of the soil and will help the farmer to maintain the pH of the soil. Okay, so we are done with the uses of alkali. Now, what we are up to? Now we are going to understand the type of acids as well as bases. So if you are understanding the classification for acids, the similar is for the bases, right? So let's start it. So we can classify acids on the basis of depending on source. Source means from where we can obtain them. So it can be natural, derived from nature, or it can be derived from, or it can be synthesized by men in the laboratory. So we call it synthetic. Right? So if I talk about in the terms of acid, if the acid is derived from natural resources, or you can say from the plant or animal, we call it organic acid. Organic is a very fancy word nowadays. Yes, you want to eat organic fruit, you want to eat organic things. So what is it? That coming directly from the plants or animals, right? There is no human intervention. So basically that is organic. Now organic acids are, what can be the example? Your citrus acid, citrus fruits, right? They are rich in organic acids. Now inorganic acids, they are synthesized in the labs. They are also known as mineral acids. We will be dealing with more examples in the upcoming slides, so don't worry about that. Next classification can be done on the basis of strength. Who's more powerful? So it will be strong acids, it will be weaker acid. Similarly, if we talk about bases, there will be strong bases, there will be weak bases. And next is depending on the concentration. That means how much amount of acid is there and how much amount of water is there. So if acid is more, amount of acid is more than water, it is known as concentrated acid. If water is more than acid, it will be diluted. Similar in the case of bases, right? So we will be discussing them one by one depending on the basis of source. So we have organic, we have inorganic or mineral acid. Organic acids are those which are obtained from plants or animal, as I told you, coming from nature, derived from nature. So they are naturally occurring, right? But the inorganic acids are inorganic compound coming not from animal or plants, not coming from the nature, but are synthesized by human interventions. Right? So bacha, let's check point number 2. Organic acids are poorly dissolved in water. I will be explaining this point later. Poorly dissolved in water. But Inorganics are dissolved in water. Next, you see, organic acids are typically weak because we can consume them. In your curd, we have lactic acid. In the tomato, we have oxalic acid, right? We are consuming them every day. In the lemon, we have citric acid. So we consume them. It's not that harmful. So we can write they are typically weak acids. But if I talk about the mineral acid, they are strong and corrosive. We cannot even imagine to eat them, touch them. Yes, now we have the lovely examples here. My dear students, ethanoic acid in vinegar is organic acid. Again, methanoic acid, it is present in the ant and nettle sting. Citric acid is present in the citrus fruits like oranges, like your lemon. Malic acid is present in apple, right? There are different examples. You can also add some more examples. Now, examples of inorganic acid, that's the carbonic acid that is found in the fizzy drinks or the soft drinks. Yes. Now, weak hydrochloric acid that is present in the stomach for the digestion process. Nitric acid, the queen of chemicals, is used in the fertilizers. Now we have sulfuric acid, which is used in the car batteries or the paints, right? So these are basically the examples of organic and inorganic acids. Now this point, dissolve poorly in water and dissolve well in water. So for solubility, we follow a rule in chemistry, solubility. Always remind of that. Solubility has only one rule in chemistry, which is like, dissolve, like. What that means? Like, dissolve, like. That means, I will give you one example. Suppose you have many friends, right? So your friends will be having the idea or the communication or the, fashion style just like you. Because you like them, they like you, right? So you all are having something common. That's what your friendship is all about, right? So that is like, dissolve, like. So we are very comfortable with the people who are just like us. Yes or no? We are very comfortable with them. We are very uncomfortable with the people who are not exactly like us. So similar happens with the acids or the bases. When I talk about water, it has ions, H positive ion, OH negative ion. Yes or no? So I can call it that the water can ionize properly. So when I am going to add this acid into this, so it should be ionizing. Yes or no? Because when I talk about water, it is ionizing in nature. It has H positive, OH negative ion. It will be more suitable, it will be more comfortable with the acid or the base, which will also be having ions. So if I talk about organic acid, they do not completely ionize. If they do not completely ionize, there will be no clear, ions of their acids. If I talk about the mineral acids, they can completely ionize when they are dissolved into the water. So they have common features. So they dissolve well in water. They don't have common feature, so they poorly dissolve in water. Right? The example was very suitable. Yes, of course. Now, going to the next part, that is depending on the strength. Who is more powerful? The question is, who is more powerful? So how can we answer this? Do they have some, feature so that we can check them by seeing them? Not at all. So depending on the strength means, strength of an acid means to what extent dissociation of acid can take place, or what extent dissociation of a base can take place. So you see, my dear students, if there is one acid like HCl, in aqueous, it will be forming H positive ion and Cl negative ion. Yes or no? So it is completely dissociated. So it is completely dissociated or ionized. I can write this. So if it is completely ionized, dissociated, I will call it a strong acid, because I will be getting readily the H positive ion, and according to Arrhenius I will be getting the axis of H positive ion. Yes, because it can dissociate. When it is going to dissociate, it will release more and more H positive ion. So I will call it better strong acid. What if I talk about, there are some acids like you see HCl giving you readily the H positive ion. If I talk about weak acid, we have the organic acids such as acetic acid, or we call it ethanoic acid. So it does not completely ionize. What happens? After some time, this H will be attached back to this ion, right? And there is no complete dissociation. In that case, we will not get excess of H positive ion, and we will call it weak acids. In the case of bases, it will be like those bases which give you OH negative ion readily. They are the strong bases, while the other which are not giving you readily the OH negative ions, that's the weak bases. So are we all good with this? Now, degree of dissociation, what is that? The amount, the extent of dissociation of acid is known as degree of dissociation. In the higher classes, you will be dealing with numerical associated with this topic. But right now, this is okay to understand how an acid or base can dissociate. So it is represented by alpha. What? This degree of dissociation can be represented by alpha. So the strong acid completely dissociate in the ions, while the weak acid partly dissociate into the ions. Now, very much important is aqueous or water, right? They can only dissociate, they can only show their acidic or basic behavior in aqueous solution, right? Not in the dry condition. This is very important line. Now, acid dissociate constant is higher value, of course, there will be more dissociation. So alpha will be high in this case, while alpha will be low in this case. Are we all good? Great. Next is depending on the basis of concentration. Concentration is very much easy. If acid or base amount is more than that of water, we call it concentrated. Dilute is when if the water amount is more than that of acid or base. So we call it diluted, right? So acidic solution has small quantity of water and large quantity of acid. We call it concentrated. And in chapter 1, we understood how to write the chemical equation. We clearly, specifically write that if the acid we use is concentrated, we use this term. Suppose the acid is HNO3, right? In the case of dilute, we have to write dilute H2SO4. We have to mention the concentrations. Yes, of course. Now, you see the large quantity of water and small quantity of acid, such kind of acids are known as dilute acid. Now, very important, that's a physical property. So, we will be dealing with physical and then the chemical properties of acid and bases parallelly. So, you see, the taste of acid for the acids is sour. The taste for bases is bitter. B for bases, B for bitter. Don't forget that. And if I talk about their touch, right? So acids don't have that significant touch, but yes, bases have slippery touch, right? Like if you are, washing your hand with the help of your soap or something, so your hand's gonna slip over each other. So that's the touch a soap can show you. Now you see nature. Acids are generally corrosive. See, I told you generally, right? While I talk about bases, they are less corrosive as compared to acid. If I talk about a strong acid, the corrosive nature is compared between a strong acid and a strong base. More corrosive will be the acid as compared to the base, right? But yes, both are corrosive. We cannot take the risk of doing that activity. Now you see, we have physical state. Generally, acids are solid and liquid. Similarly, the bases are solid and in liquid state they exist. There is one gas that is there's one gas that is HCl. In gaseous state we call it hydrogen chloride. When we make its aqueous solution, and we call it hydrochloric acid, right? This is the aqueous form of hydrogen chloride. So are we good? Yes. Now the indicators. Indicators actually indicate with changing the color or their essence, right? They will be letting you know whether the solution is acidic or basic in nature. In the upcoming slides, we will be covering this topic, indicator. So for now, we can get the idea of electrolyte. So what are electrolytes in the case of acid or bases? Electrolytes are something which are electrical conductors. They can, they can allow the light pass through them. They can allow the path of ions to pass through them. Electrical conductors. Right? So now what is electrical conductors? Acid and bases both can be electrical conductors. Now I will let you know what is conductor. So suppose you have a bus. Have you ever traveled into the bus? Yes or no? Do let me know in the comments. Suppose this is the bus. Okay. So this bus, there are two people. One is the driver and the two is the conductor. Yes, one is the driver and the two is the conductor. So driver drives, only drives, okay, from one place to, suppose A place to B place, right? It will drive only properly. And the conductor actually allows you to sit into the bus. Yes, and also give you the access to travel from one place to another. That is the function of a conductor, not the driver. Driver only drives, right? Now you see, my dear students, if you are sitting from this place and reaching to this place, what you are doing? You are moving. You are showing movement, right? If it is in the case of people like us, we call it movement. But this movement can be, shown by the ions or electrons. So when the ions or electron move from one place to another, that is also conductivity. Yes or no? So as I told you, both the acids, bases can be electrolytic, can be electrolytes. Electrolytes are those which can conduct electricity, which can conduct electricity. Conduct means there is movement of ions or electrons, right? Then only it is supposed that the acid is electrolytic or the base is electrolytic. There are many factors, but yes, what that means, conductor, electrolytes, this is written here only. Yes, are we good? Great. Now the chemical properties. What are the chemical properties? Chemical properties are some reaction that will give you the idea of a acid and the base. So acids generally react more. You see, acid react with bases. Of course, acid reacts with metals, number 1, and its derivative. Derivative means derived from metals. So they can be metal carbonate or hydrogen carbonate, or they can be metal oxide. So 1, 2, 3 and 4. These 4 type of reactions, very important. Now, if we see the reaction of bases which are very much less in number. So 1, they react with metal. 2, they react with non-metal oxide. 3, they react with acid. Okay. So question arises, why bases do not react much? Why? So generally we see the bases are not going to react with a large number of metals. They are going to react with 1, 2, 3, 4, only few metals. Why? See, because the reason is bases, according to Lewis, right? For this moment, I am taking the definition of Lewis, right? According to Lewis, bases are electron donor. Donor, that means they are electron rich, of course. Can I write this? Donor are those now. If I am having something in excess, I will be able to donate that. I will be able to lose that. Yes. So both the things are same. What if I talk about metals? Metals also donate electrons. Yes or no? Recall sodium. It donate 1 electron, acquire 1 positive charge. What is that? It was having excess of electron. It was rich in electron. It can donate electron. So suppose there are 2 donors. So there is no balance. Both wants to donate. Nobody wants to accept. Suppose Elon Musk and Ratan Tata both have much of, power. Both have much access of money. So both can donate. Nobody wants to accept. Yes or no? Now you see, if your metal and a base both are standing in front of them, so they are on the same page, right? So nobody wants to accept, so they won't react much. Okay, are we good? But yes, there are some metals which are going to react with bases, and we will see those reactions. So are we good? Why bases are not reacting much? To maintain the balance, whenever we do some reactions, there would be electron donor species, there would be 1 electron acceptor species. Then only we can balance things. Okay, now let's discuss these reactions parallelly in the case of acid and in the case of bases. So when acid reacts with metal, it's a very good reaction. So when acid reacts with metal, it will form salt plus hydrogen gas will be evolved during the reaction. Now this evolution of hydrogen can be identified, can be determined by using that pop sound experiment. What is that? So I will be letting you know what is that. Before that, I will be taking one example. This is the general form of reaction. You have to understand this. When acid react with metal, suppose you have HCl, okay, aqueous, it will give you, suppose we have Zn, it will give you ZnCl2, which is a salt, and there will be evolution of hydrogen gas. So in this, whenever this reaction is going to happen in the test tube, suppose this reaction is happening in this test tube, we see ZnCl2 is formed in this test tube and hydrogen gas is escaping. Of course, gases have a tendency to escape. Yes or no? Now, my dear students, when you place a burning matchstick or a burning candle, these hydrogen bubbles, when came in contact with this, they will burst and it will produce a pop sound. Why? Because hydrogen is an explosive gas. Yes or no? right? So this kind of reactions happens in when acid reacts with metal. Can you tell me what kind of reaction is it? Yes, it's a kind of displacement reaction, right? So you have to recall your reactivity series. What is reactivity series? In this, the metals are arranged in the decreasing order of their reactivity. The topmost metal is highly reactive and the bottom one is less reactive, least reactive. So I will write this for you. So this is a complete reactivity series. Now you see in this reactivity series, we have master hydrogen. Yes or no? This is the reactivity series for metals, but there is one non-metal, that is hydrogen. So what is the function of this hydrogen? You see, the metals which are below hydrogen are less reactive than hydrogen. They are not able to replace hydrogen from water or acids, right? If I want to write HCl plus copper, it will not react. Why? Because copper is less reactive than hydrogen, so it cannot displace hydrogen from acid or any water solution. Are we good? While the metals which are before hydrogen or above hydrogen can simply displace hydrogen and can proceed this reaction. So are we all good? Great. Now we have base react with metal. As I told you, base generally do not like to react with metals because both are having the same nature, electron rich, both have that ego. They are not going to react much. But yes, when base react with metal, it will also form corresponding salt and there will be evolution of hydrogen gas. Let's take the example. Suppose I have NaOH that reacts with zinc. It will give you Na2ZnO2. Can you name this? What is the name of the salt? Yes, of course, that's the sodium zincate. Sodium zincate. Lovely, right? So we have covered when acid reacts with metal and bases reacts with metal. Now, acid reacts with bases and bases reacts with acid. It's a very famous reaction in chemistry. What is it? Name it. Yes, of course, it's a neutralization reaction. So I can write, suppose there is one acid reacts with base. It will be forming corresponding salt plus water. Now, what can be the acid? Suppose that's the HCl, base NaOH, making NaCl plus water. Now, this reaction seems so easy, but it has many significant values. I will let you know very soon. So, if I talk about the same in the case of base react with acid, again it's a neutralization reaction. When we perform this reaction in any beaker, right? If we perform this reaction in any beaker, the temperature of the outer wall of beaker increases. That shows that this reaction is highly exothermic. Not that highly, but yes, it is exothermic. Now, we have covered when acid react with base or base react with acid. This is the kind of neutralization reaction. Now you see what is the application of neutralization reaction. Why is it important? So, getting the idea of slaked lime. Yes, slaked lime is added to reduce the acidity of soil, of course, which helps the farmer, and acid tablets, which is milk of magnesia. Magnesium hydroxide, milk of magnesia, is used to treat the acidity to neutralize the excess of HCl that is produced in the stomach. Right? Now we have the sting of ant or bees containing formic or methanoic acid. When it is injected, we feel very irritated. It is very painful. So it can be neutralized by rubbing the soap. Very much easy and very much useful. Sting of a wasp that contain alkali. Don't get confused, right? When I talk about ants and bees or the nettle, leaves of the plant, they all contain formic or methanoic acid, which can be treated, which can be neutralized by using some basic solution like soap. But the sting of wasp is already alkali. So we have to treat it by neutralizing vinegar or citric acid. Are we good? Of course, yes. These are the important applications of neutralization reaction. Now, my dear students, we are proceeding when acid reacts with metal oxide and bases react with non-metal oxide. You see, the difference is very clear. Acid choose metal oxide, bases choose non-metallic oxide. So here we want to confirm that metallic oxides are generally basic in nature. We are going to prove this. And the non-metallic oxides are generally acidic in nature. Right? If the examiner wants you to ask, how you can say the non-metallic oxides such as CO2, such as SO2, these are acidic in nature. So you have to write these reactions. Now let's proceed without further ado. Suppose I have one acid. It reacts with metal oxide, forms corresponding salt and water. There is a catch. Did you find it? Right. Now, if base react with a non-metallic oxide, that's not NaMO, that's non-metallic oxide, it will give you salt plus water. Ta-da! There is again a catch. Did you find? Of course, the general equations, the general reaction shows something like neutralization reaction. Yes or no? So, suppose I have one acid, suppose I have HCl and then I have copper oxide. It will be forming CuCl2 and there will be formation of water. Are we good? Great. Now, you see this salt formation, this water formation, when acid react with bases, that comes. Yes or no? But if I place base and metallic oxide, I can replace them. The results are same. So can I say that the metal oxides are what? They are basic in nature. Because if I compare this with the neutralization reaction, which is acid plus base gives you salt plus water. Can you compare things? Same, same, same. So it will also be same. Great. Now, base react with non-metallic oxide gives you what? Salt and water. Again, what can be the base? Suppose I have NaOH and then I have CO2. CO2 is the oxide of a non-metal carbon. It will be giving you Na2CO3 plus water. Ta-da! Now you see, I can compare it again. So this is my base, right? This is the salt, this is the water. The remaining part is going to be acid. Right? So I can say this acid in aqueous, yeah, that means this acid CO2 when it is in aqueous state means react with water gives you acidic solution. Similarly, this base when reacts with water gives you the basic solution, and that's how we can prove these things. Okay, One thing I want to add is when acid react with metal, generally there is evolution of hydrogen gas, but there is one acid which there is no evolution of hydrogen gas, but that produce water. What is that? That's your HNO3, which is your queen of chemical, which is your queen of acids. So if it is regarded as queen, it will be having some tantrums, yes, so it will be giving a different reaction. So you see, if I have one HNO3 reacting with, suppose I am having sodium, so it will be forming NaNO3. It should be like H2, right? But because HNO3 is strong oxidizing agent, right, it will be oxidizing this hydrogen quickly, right, and it will be forming it water. Suppose she is the queen, the reaction is proceeding, see, observe that hydrogen is all alone and she has a mercy. She provides this hydrogen, one oxygen, and making it water. So it can be done in the case of HNO3 only. Now you have to add few points here. Why HNO3? Show this reaction. Because it is strong oxidizing agent. Oxidizing agent. What is that? In the chapter 1, when we were discussing redox reaction, we got to know what is oxidizing and reducing agent. Oxidizing agent is what can provide you oxygen. So it is providing hydrogen, one extra oxygen, making it water, right? But yes, there are two metals like manganese and magnesium. When HNO3 reacts with manganese and magnesium, they can produce their corresponding salt plus H2. This is a different case. I want you to notice this. Great. We done this? Of course. Now we have what? We were proceeding next. Done this? Of course. Now we have when acid reacts with metal carbonate or metal hydrogen carbonate. What happens? And bases do not react. I clearly want to say base do not react much. So bases are not going to react with metal oxide or the metal derivative much. Now you see acid when reacts with metal carbonate gives you the corresponding salt plus CO2 plus water. See, next is when acid reacts with metal hydrogen carbonate, it will give you corresponding salt plus CO2 plus water. No change in the products. I will write the reaction first. So suppose I have one acid which is HCl, reacts with metal hydrogen carbonate, suppose Na2CO3, that will give you NaCl plus CO2 plus H2O. This will be an aqueous, right? Now you see this acid react with metal hydrogen carbonate, HCl reacts with the reaction in aqueous proceed faster, because in the case of aqueous they are into the ions and the positive ions are getting attracted by the negative ions and vice versa, they are forming products faster. So we proceed reactions in aqueous medium. Now we have the metal hydrogen carbonate. Suppose sodium bicarbonate or sodium hydrogen carbonate will give you again Na2CO3 with the evolution of CO2, and H2O. Water is formed. What is the interesting part? Now you have to detect the evolution of CO2 is in this reaction. What is the evidence that there is evolution of CO2 gas? So that's your very important test. We call it lime water test. Do you recall what is lime water test? It is done for detection of CO2 gas during some chemical reactions. Now you see, in this reaction, what we do, in this test, what we do, basically we have this reaction, we proceed this reaction in some test tube or the beaker. Now we can do one thing, that is, suppose if the reaction is occurring in this beaker, so there will be evolution of CO2 because CO2 is gas and gas has a tendency to escape. So it will be coming out from the mouth of the test tube or the mouth of the beaker. Now when I place a burning candle, what will happen? This burning candle will blow out. Why? Because CO2 is a non-supporter of fire or combustion. Are we good? This is one. What is the lime water? That is number 2. So I will explain the lime water test. What is that? Lime water test for detection of CO2. So in this, when we are proceeding with the previous reaction, when acid reacts with metal carbonate and metal hydrogen carbonate, you see there is evolution of CO2, right? Everywhere. You can check that. So now this CO2 is, we have lime water. What is lime water or slaked lime? Which is calcium hydroxide. This calcium hydroxide is passed through the CO2 gas and it will be forming, yes, of course, calcium carbonate and water. Right? So you see milkiness appears. Milkiness. Milkiness appears. Now this milkiness disappears when, if I pass excess of CO2. So suppose this is your product. If I pass more CO2 from this, it will be forming calcium hydrogen carbonate, right, which is soluble in water. Soluble in water means it will not show any color. It will seems like water only, like you dissolve NaCl into the water, right? There is no change in color. Similar happens when you pass excess of CO2. Excess of CO2 means first you are passing CO2, right? There will be milkiness because this calcium carbonate, which is also known as marble, right, that is not soluble in water. If it is not soluble in water, it will seem like milky. The solution will seem like milky. But when I pass excess of CO2, the reaction will proceed like this and will produce a salt which is soluble in water. So that milkiness disappears. Milkiness disappears. Great. So this is kind of very, very important. Right? Now, let's proceed. What we have? pH. Now we want to understand the strength of acid or a base. So that was given by Sorensen, pH, right? So pH means potence or power of hydrogen. Yes. Now you see, the strength of acid and a base is given in the term of pH. Now in German, pH means potential of hydrogen, that means the power of hydrogen. Right. Now the strength of acid and base depends on the number of H positive ion and OH negative ion. I told you. The acid is going to be dissociated in the aqueous state. Right. The same is going to happen in the case of base. So they are going to dissociate into ions, and more is the H positive ions. That will be indicating stronger is the acid. More is the OH negative ions. It will be indicating the more basic solution is there. Okay. Now the scale measuring for hydrogen ion concentration. Why hydrogen ion concentration? Suppose, okay, I will be explaining it later, but yes, solution is called pH scale. Now we will be discussing more about it, but before, let's take a break. Right? What that break? We are going to understand or detection of acid or base. Suppose you are given with the test tube, right? In the sample paper, you can also get some questions like this. Both are colorless. We started this chapter with the activity like this, right? Both are colorless. We cannot taste them. So how can we indicate them? I told you, we are going to study the indicators, right? So indicators indicates or identify the nature of the solution, that can be acidic, that can be basic. So they can change their color, they can change their order when they are placed in acid or the base accordingly. Interesting. They are very smart. They are not having eyes, but yes, they can definitely let you know that whether the solution is acidic or basic. So basically we have indicator. Indicator is something which indicates, right? Indicates or give you the signal, give you the sign. So basically we have three type of indicator. One is the natural. Natural means coming from plants. Synthetic means man-made. They are, prepared in the laboratories. And then the olfactory. Olfactory, those which can be detected by their odor or smell. Change in odor or smell. Also important class of indicator. Now you see, in the natural we have the example of litmus. Litmus derived from the lichens, purple color of dye. They have natural purple color of dye. Synthetic is methyl orange and the phenolphthalein. Then we have the olfactory indicators, that can be onion, that can be your vanilla essence, right? And the clove oil also you can add. Now see, we have the litmus, turmeric, red cabbage, China rose. All are natural. What is common in them? These all are natural and they show change in color according to the solution, whether it is acidic or basic. Now you see, litmus generally shows red color in the acidic solution and blue in the basic solution, and in neutral there will be no change, of course. If I talk about turmeric, turmeric show no change in acids, but it show the change in color, which is reddish brown in the case of basic solution. Suppose you are eating something, going for the school, getting late for that, and you see there is something fallen on your shirt which is white in color. So what will happen? So it was having some turmeric, it fall on your shirt, white shirt. Now what gonna happen? Yes, so basically when we go and try to wash it with the help of detergent or the soap, it will turn the color into reddish brown. What is the reason? Because the soap or the detergent is basic. Yes or no? We already have discovered that, right? So that is a change in color, and in the neutral there will be no change. Again, coming to the red cabbage, it showed reddish pink color in the case of acid, bluish green in the case of basic, and remains purple in the case of, which is the natural color of this red cabbage, right? That is the natural. Now, China rose. China rose shows dark pink color in the case of acidic. Basic color it will turn into green, which is very beautiful. And in the neutral solution, there will be no change in color. Now, let's talk about the synthetic indicator. We have phenolphthalein, we have methyl orange, right? So, here you can see the phenolphthalein is generally colorless. Colorless solution. If we dip some drops of phenolphthalein in acid, there will be no change in color, while in the case of base, it will turn it into pink. You see, this is the acidic solution. So, there is no change in color, while if I add this into NaOH, suppose that was HCl aqueous, right? It will turn this solution into this beautiful pink color. Now, if I talk about methyl orange, so methyl orange is basically yellow in color. The natural color of methyl orange is yellowish. So, in the case of acid, we see it's kind of pink, or we call it orangish pink, right? While in the case of base, the natural color is intacted, right? So, this is how, with respect to change in color, we can identify the solutions. Now, we have some olfactory indicators. Suppose I can write here, that is your onion, vanilla essence, we have clove oil, right? So, my dear students, they have some characteristic smell, yes or no? But in the acid, they intact that smell. The smell is there. But in the case of base, if I dip them in base, there will be no characteristic smell of these. So, if there is a visual impaired student who want to identify whether the solution is acidic or basic, that can go with olfactory indicators, right? So, that's amazing. Now, we have again the pH. Okay, so this is the slide. Let me show you. In 1909, Sorensen, right? Sorensen developed a scale known as pH scale. Mr. Sorensen, they developed a scale which is known as pH scale, which the strength of acid solution as well as basic solution could be represented by making use of the hydrogen ion concentration. As I told you, why hydrogen ion concentration? See, for bases we have to know about the OH ion concentration also. But he was very much smart. He took only one thing, which is pH. Mathematically we can write pH is the minus logarithm of hydrogen ion concentration. What that means, I will let you know in a moment. But yes, there are two things. One is the H positive ion, other is the OH negative ion. If I get the idea of H positive ion, I can definitely count the OH negative ion. What the example? Suppose in your class there are 40 students, right? Total 40 students. Suppose girls number is 30. So, can I detect how many students, how many boys are there? That's very much easy. I can subtract total number of the student from the number of girls, which will be 10 only. Right. So, that was the idea of Sorensen. He gave you a scale up to 14, 1 to 14. And he said that if the H ion concentration increases, OH ion concentration will decrease. I'll show you the very important diagram for pH scale. So, this is right. Suppose this is number 7. It starts from 0 or 1, hardly matters, up to 14. This is about your pH. So, up to 0 to 7, that's the acidic character, right? 7 to 14, that's the basic character. Now, you see, I will write 1, 2, 3, 4, 5, and this is, okay, this is 6. Again 8, 9, 10, 11, 12, and this is 13. This is H positive ion concentration. This is OH negative ion concentration. Check the area of OH negative ion. Check the area of H positive ion. Right? If suppose I say pH is equal to 9. So what ion concentration is higher? H positive or OH negative? Let me know. So I will check this diagram where we are 9. Okay, so draw a line. This is for H positive ion, and now I will be doing a line here also. So you see which is more, which length is more. So this line is not accurate, so length of this will be higher. Okay, we will be taking some other examples, so it will be basic in nature. Suppose we have some other examples. Suppose pH is equal to 1. Okay, now it will be very clear. So 1 is here. You see the length of H positive ion, there will be this number of H positive ion, and this will be OH negative ion. You see this number, right? This number is for H positive ion. So let me know which ions are in excess when pH is equal to 1. H positive ions. Yes, and OH negative ions are in less in number. Excess. So this is the idea given by Sorensen. One thing I would like you to note, that is, if the pH is 1 or 0, you can clearly see there is still OH ions present into the solution. If the solution is acidic or basic, the acidic will be having excess of H positive ion, which is true. It will be having excess of OH negative ion, that is true. But read it mindfully. Excess of H positive ion means there will be higher of H positive ions. It is not written that for being acidic, it will be completely H positive ion. Excess, that means there will be some ions in negligible amount. Yes, in this case, the negligible amount will be for OH negative ions. Right? And excess of OH ions, that means there will be some ion in negligible amount. That will be H positive ions. So always remember this. There is no complete solution having H positive ion, no solution having complete OH negative ion. We always say, according to Arrhenius, acids are those when dissolved in water give you excess of H positive. Right? So there will be negligible amount of OH negative also when we are talking about acid, and similarly in the case of basic. So are we good with this Sorensen pH scale? Now we have to discuss 4 more points. Is this clear? pH is equal to the minus logarithm of H positive ion concentration. What that means? Is it directly proportional or inversely proportional? I will like to write inversely proportional. What that means? That means if pH increases, the number of pH increases. pH is the scale having number from 0 to 14, right? If the number increases like 2, 3, 4, 5, 6, 7, 8, right? So the concentration of H positive decreases. So can I write this? That the pH, number of pH increases, OH ion concentration increases. Yes or no? See here, Acidic solution, if you see, if you check acidic solution, the pH is less than 7. If I talk about the neutral solution like water, we have the pH is equal to 7. If I talk about basic solution, you see the pH value is more than that of 7. So that is how we got the idea of strength of acids and base, right? If we have two acid, similarly, right, before we were doing what is a strong acid, what is a strong base. Right now we have to choose between the acids. Suppose you have three acid, acid A, acid B, acid C, right? They are having different pH. Suppose you are having three acid, pH is equal to 1, pH 2, pH 3. Which one is the strongest acid? So it will be answered by this pH scale, right, which says pH is equal to the minus logarithm of H positive ion. So the more acidic will be 1, 2 and 3. This will be more acidic, the intermediate, the least acidic, right? Also we can further divide this scale 0 to 3.5. It is strongly acidic. Strongly acidic. 3.5 to 7, weak. 7 to 10.5, this is weak basic, while 10.5 to 14, strongly basic. Are we good with this? Okay. So this is all about pH. So pH scale is very much important because the human life or the living organism are having a very, a very short range of pH for their survival. So it's about 7 to 7.8. Right? They are different stuff having different values of pH. That is in this diagram we can clearly see. If I talk about the batteries in the car, which is sulfuric acid, it will be having the value equal to 0, which is highly strongly acid. And if I talk about the stomach acid, having the value equal to 1. And then we go to the drain cleaner, which is caustic soda. Right? Drain cleaner that clog the drain. So which is the strongest base, having the pH value equal to 14. So this is the pH value. If I talk about blood, that is about 7.4. Okay, not exactly 8, but blood has 7.4. The acid rain have a pH equal to less than 5.6. Right? That corrode the monuments made up of calcium carbonate. Yes, of course. So this is how we are getting the idea of pH values of different substances around us. So is that clear? Now, uses of pH. So Sorensen did a great job, give you the idea, right? We got the knowledge of where the things are, acidic or basic. If I talk about water, so water is assumed to be neutral. Why? Because it has, if I ionize this water, it will be ionized into H positive ion, OH negative ion. The equal number of H positive ion to the equal number of OH negative ion. So for H positive ion, if I consider it acidic, so for OH negative ion, I have to consider it for base, and both are having same concentration. So I can call it neutral, because for being acidic, it should have more H positive ions, and for being base, it should have more OH negative ions, but both concentrations are same, so I can call it neutral. Now you see one more thing. Total pH values are up to 14. So this sum can be written as pH is equal to H ion concentration plus OH ion concentration. right? H ion concentration means 10 raised to the power minus 7. Yes, because 0 to 7. Next, OH ion concentration is again 10 raised to the power minus 7. 7 to 14. So basically this is all about 10 raised to the power 14. Total number is 14 always. As I told you in the example, we have total student number, that is what? That is 40. If I know the number of girls which are 30, I can write the number of boys which is 40 minus 30 equal to 10. Similar happened in this case. Now pH is very much important. How is it important? You see, plant and animals are pH sensitive, right? So when pH of the rainwater is less than 5.6, we call it acidic rain. Acidic rain. Can you imagine acidic rain? What can be the harmful effect of the acidic rain? So when the pH of rainwater is less than 5.6, it is called as acidic rain. When this acid rain falls into the river, it lowers down the pH of the water of the river. So the survival of aquatic life such as river becomes very difficult, and you can see this image where the fish are dying because of this acidic water due to this contamination. They are not getting the proper pH to survive. So basically I can clearly say that they are pH sensitive, plants and the animals. Also, you see, the farmer require neutralization reaction using the caustic soda in order to balance the pH of the soil, right? Now you see, pH change is the cause of tooth decay. You see your healthy teeth which seems like this, while your unhealthy teeth seems like this. So tooth decay starts when the pH of mouth is lower than 5.5, right, which is acidic. You see, 0 to 7, acidic medium. 5.5 means it is acidic. Tooth enamel is made up of calcium hydroxyapatite, which is the salt of calcium phosphate. Yes, so that is the salt of calcium phosphate. It is hardest substance in the body, in the human body. You know that, right? Again, it does not dissolve in water, but it is corroded when the pH in the mouth is below 5.5, which means it is more acidic. It reacts with the tooth enamel, from where these are coming, this acidic medium. So basically when we are chewing something for a longer time, the leftover part in our mouth produce bacteria. They try to digest that. During that process, they produce bacteria, and these bacteria are responsible for the production of acid, or the level of acidic medium that increases in our mouth, which affect this enamel. Bacteria present in the mouth produce acid by degradation of sugar and food particles remaining in the mouth after eating. So it is always advised that you have to brush your teeth 2 times in the morning and before going into the bed, right? Also, you can wash your mouth properly after eating anything to avoid this. The best way to prevent this is to clean your mouth after eating food, which is great. Also, you are using Colgate or any toothpaste, right, which are basic in nature. So they actually neutralize in your mouth and your enamel remains intact. Now we have the pH in the digestive system. So you know that during digestion we have the HCl, which is responsible for breaking down or decomposition of food particles which are complex to the simpler substances, right? So our stomach produces hydrochloric acid, which is a well-known fact. It helps the digestion of food without harming the stomach, right? During the indigestion, the stomach produces too much of acid. If you are eating something which is very oily, right, in order to digest that, your stomach produces more and more acid. So in that case, you feel pain, irritation, and to get rid of this pain, people use bases like antacid. You might have seen that advertisement of Eno, right? That's the antacid, the example of antacid. The antacid actually neutralize the access of acid. So in the Eno, they claim that in 6 seconds you are getting the relief. Why? Because the neutralization process is very much fast. So these antacid neutralize the access of acid in few seconds because the reaction is very fast. Magnesium hydroxide or milk of magnesium is a mild base which is often used for this process. You can see this is your stomach and these H positive ions are indicating these are excess in number, increasing the acidity, giving you more pain and discomfort, right? So pH is balancing that. Now we have the self-defense by animal, plant through the chemical. So self-defense is very much important, right? Honeybees sting leaves formic acid, right? Honeybees, which cause pain and irritation when they stung us. So use of a mild base like baking soda on the stung area can provide you relief. So this is your bee. See what is present in its sting, that is the formic acid. We call it methanoic acid. Sting hair of the nettle leaves. These are the nettle leaves, right? So basically they contain the methanoic acid, exactly the same in the case of bee sting. They cause burning pain, and in order to avoid that, in order to get comfort, we use the dog plant. In the comments you can let me know the function of dog plant, why we are applying dog plant when these leaves give us discomfort. Okay, now we have, let's know more about salts. Already we have covered this acid, then we have covered bases. We are come up with salts, which is very much interesting. So salts are formed by the combination of acid and a base, combination of acid and base through the neutralization reaction. I told you neutralization reaction is full of secrets, right? I will let you know in a moment, but yes, you see the salt is ionic compound, any salt. If I place NaCl, so salts are ionic in nature. Ionic means they are formed with the help of ions. Like if I decompose this NaCl in the aqueous medium, I will be getting Na positive or Cl negative ion. Yes or no? Of course. So these are the ions. Yes, so ionic compound which dissociate in water to yield a positive ion and other than H positive. If I dissociate NaCl, it will be showing one positive ion. Is it look like H positive? No. So it will be giving out one positive ion other than hydrogen and a negative ion other than hydroxyl ion, right, which is OH negative ion. Now acid and the basic nature of the salt. Sometime you might have heard that this salt is basic. If I talk about NaHCO3, sodium bicarbonate, which is used to treat stomach acidity. Why? Because it is considered to be basic. But when you say that these are the salt, they are formed by the neutralization reaction, by the combination of acid and a base. So what is mean by this salt is basic in nature? What that means? So we are going to deal with that question in a moment, but yes, the acid and basic nature of the salt depends on the combination of acid and the base we are taking in order to proceed with the reaction of neutralization. Now how can we form salts? What are the techniques, what are the reaction we can involve for the formation of salts? So basically, my dear student, we already know when acid and base react, they form salt and water. So this can be a one method to prepare salt. Number two, when metal react with acid, recall this reaction. Yes, of course, it is the chemical property of acid. So when metal react with acid, it form corresponding salt with the evolution of hydrogen gas. Again, double displacement reactions. You have to write down one example of double displacement reaction in the comments and let me know what salt did you produce, right? So this is how we can prepare salts. Now, very interestingly, I just wanted to know what are the acidic salt, what are the basic salt, and what are the neutral salt. And how can I recognize that? Because this can be one of the favorite question of the examiner, right? I can write star mark. So basically, as I told you, the neutralization reaction is full of secrets. Let's start to reveal them. So I am forming water. So I am taking that neutralization, a strong acid reacts with a strong base. That means the acid and the base are of equal strength. So they will be forming a salt which is neutral, because suppose both are balanced, having the equal strength, they will be balancing each other, right? So the salt they are going to form is going to be completely neutral. The pH is going to be 7. Now, you see how to do these reactions. Suppose I have HCl and NaOH. Don't forget, this reaction is going to be happen in the case of aqueous. As I told you, acid and base show their character in aqueous. Why? Because in aqueous they dissociate, and on dissociation they show axis of H positive ion or axis of OH negative ion, which is the definition of acid and base, right? Now you see HCl reacts with NaOH. Watch this carefully. So H, NaOH. So whenever we write a compound, there are some rules. These rules are not formed by us but IUPAC, right? All the modification, all the changes can be done by IUPAC. That is going to be studied in the chapter 4, carbon and its compound. That's an organization. Now, compounds, when we are writing a compound, positive part is placed before the negative part. Are we good? This is the idea. Now you see, in the case of HCl, H is the positive, Cl is the negative. Of course, NaOH, N is the positive, OH is the negative. Now, as we all know that positive negative attracts. So, this positive part of HCl is attracted by the negative part of NaOH and it will be forming water. No difficulties? Yes. Now, the Cl of the HCl and the positive part of the base reacts and makes NaCl. Recall this. Positive part is written first, then the negative part. Yes, followed by the negative part. Now you see the positive part or the metal part. The metal part or the cation. You know what is cation? Having positive charge. The species which acquire positive charge, that is actually metal, and that is known as cation. So cation, the metal part, is given by the base, while this is very much important, while the non-metal or the anion part is given by acid, and then we are making a salt. Are you getting this? Are you getting this? If not, you can write it by yourself, then you will be getting the idea what I am trying to say. So basically, when I am writing this reaction, according to formation of a compound, I do know the cation is written first and then the anion in the case of ionic compound. So I write it like this. Now, when the positive part of this acid is attracted to the negative part of the base, we are forming water. What next? The Na, which is the metallic part, which is the cation, is placed first. So, the salt's first part is attributed by, is given by a base, while the later part is given by acid. Example. Example time. So we have some characteristics of our parents, some of mother and some of father, yes or no? So in order to make this salt and water, what are the parents? This acid and the base. So in this salt, both the characters are there. So very first part is given by the base, and the second part, the last part, is given by the acid. In order to form the salt, we have two ions, one is the positive and one is the negative. Positive ion given by base and negative ion given by acid. I hope this is very much clear now. So acidic salts are those in which I will write first the neutral. When the acid and base are of same strength, they will be forming the neutral salt, and I can write the pH for them, that is equal to 7. Good. Now basic salt, acid will be less in strength and base will be more in strength. You know, the survival of the fittest, of course. So they both came for the neutralization, and we found base is more stronger. So base neutralize this acid and still existing, so the salt will be somehow as basic, right? So its pH will be around more than 7. Is it right? Now let's talk about the acidic salt. So here already I know the strength of acid was higher than that of strength of base, so the pH will be is equal to more than 7. Sorry, less than 7. My bad. Less than 7. Are we good? Are we great? Okay. So basically now you will be asking me one question, ma'am. What are the strong acid? What are the base? What are the strong bases? So basically in the era of chemicals, in the era of acid, base and salt, we have n number of acids, n number of bases. So what are the strong acids? I will be writing it for you. Strong acid and strong base. So we cannot recall all of them. What we can do, what is more easy, what is more feasible for us to recall few names, right? For strong acid, I can write there will be HCl, there will be HBr, there will be HI, right? These are coming from the halogen part, fluoro, chloro, bromo, ido. So not fluorine, this is not involved, but the hydrochloric acid, hydrobromine acid and the hydrogen iodide acid. You can say that. Now we have HClO4, we have HNO3, we have H2SO4, which are very well known, and then we have HCl. Already we have written this. No need to write again. So basically this is a name for perchloric acid. Perchloric acid. This is your queen of chemicals, queen of acid, nitric acid. Next we have your H2SO4, which is sulfuric acid. Are we good? Let me know in the comments. I have tried to make this chapter more simpler to you all. Now strong bases are like LiOH, lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide and cesium hydroxide. These are the metals from the first group of periodic table, right? Lithium, sodium, potassium, rubidium, cesium, because they are basic, they will be containing OH negative ions. Okay, now we have COH whole twice, which is your slake lime. Strontium hydroxide, we have barium hydroxide. You have to recall only these. These are the strong acid, these are the strong bases, and also you have to remember whatever the acid comes into your way. Suppose you are dealing with one acid, that is H2CO3. What is it? Strong or weak? The answer will be weak because it is not involved in this list. So whatever the acid is not present in this list of acid, whatever the base which is not present into the list of the strong bases, you are going to consider them weak for sure. Right? Chalo. Good. Now I will give you one example how we are going to get the answer of strong acid or strong base. Suppose I have NaHCO3. Right? The salt part, I want to know whether this salt is acidic or basic. I know it is basic, but what is the combination of acid and base in order to form this salt? I want to know that. So I will definitely dissociate it. Yes, even the salt can dissociate in the aqueous. So there will be two parts. One is the positive part and the remaining part is the negative part. Okay, how you are going to answer such kind of question? So you have to dissociate the salt, given salt. You will be having the positive and the negative part. You know that the positive part, the metallic part, is given by base. Yes, you can check that slide also. The negative part is given by acid. So we can collectively write this like that way. Now I want to check Na is having what base. What base is there which is having Na? Yeah, that means sodium. So I can check, okay, this is the base. Okay, yes, that's the NaOH. Right. And what about this HCO3? What is that acid? So I do recall that the carbonic acid is having a formula that is H2CO3. This is formed when water reacts with CO2. As I told you, CO2, non-metallic oxide, in aqueous gives you acidic solution. Yes or no? The carbonic acids are containing, the fizzy drinks, the soft drinks are containing carbonic acid. Of course. So the acid was H2CO3. When we combine these combination, we will be getting this salt and water. I can write it this like this, plus water. Now can you please tell me what can be the nature of this salt? You see, this base is the strong one, and if I check this acid into the list of strong acid, I cannot find it, so I can completely write it like it is weak. Simple. Weak acid, strong base. Who is going to get the survival? Of course, the base. So the surname will be basic. Are we good? Yes or no? Okay. Now, these are the some salts given here. You have to identify what. See, you have to actually practice. So basically these are the salt solution. Here it is written their nature also and the combination of acid and the base used. So suppose if I'm taking one more example of copper sulfate, that's your copper sulfate. Dissociate it, right? It will come definitely. You will be saying, ma'am, you know how to dissociate. We don't know, but yes, only the practice will let you know how to dissociate. Yes, so basically this part is positive, this part is metallic, will be given by the base. And if I talk about this SO4, this part is negative and it is given by the acid. Now you see, try to find out the combination. So copper base can be, yes, copper base can be CuOH whole twice. What about the SO4 acid? Of course, that's the sulfuric acid, the king of chemicals. Out of these, check through the list I have given to you. I can find this into the list of strong acid, but cannot find it. So what can be the answer? Yes, it will be acidic salt. You can check it. It is acidic. the acid used, the base used. Are we good with this? Can we do such questions more and more? Of course. Now, salt families. Just like we have the family names, the surnames like the Sharma family, the Verma family, the Gupta family and whatnot. Right? There can be many families. India has the great diversity, the beautiful diversity. So we can imagine the family. What about the salt? If they are having same positive or the same negative radical or the part, right? Don't get confused in this word. It can seems like more fancy, but it is very simple. You can clearly say salt having the same positive or negative ions or the parts are said to be belong to the same family. Suppose I have NaCl, I have Na2SO4, I have NaNO3. Next, suppose I have I have KCl, I have I want to write something else. I have CuSO4. Suppose I have ZnCl2, I have HCl, I have KCl, I have what? CuCl2. Now, what can I see? So basically in this part, I can see the cation part is same. Yes or no? If yes, then they belongs to sodium salt family. Wow, interesting. Of course, the family have some they have the unique but some common characteristic. You and your sibling, you and your father and your mother, they are having something in common. Yes, so similarly they are having something in common, which is the positive part. Now if I talk about this, so I can see chlorine, all are the negative parts. So what can be the name of the family? Yes, chloride. Chlorine, you cannot say, because in the negative term we can call it chloride salts. Wonderful. I will give you one homework. So I have CuSO4, I have ZnSO4, I have MgSO4. Do let me know from which family they are going to belong. Okay, great. Common salt, let's discuss some important salts, some important reactions associated with them. So basically, first I have common salt. Common salt is prominently known as NaCl, that the table salt. We usually consume it according to need, right? So basically the salt formally formed by the combination of hydrochloric acid and sodium hydroxide, of course, making the neutral salt NaCl and the water. So basically large scale production. When we want to produce it on the large scale, we have two methods. One is from the seawater. So we see the Tata Namak. Yes, so basically from where we are getting it? From the seawater. Seawater contains the dissolved salt which is obtained after evaporation. So basically we have some shallow pools near the seawater. We have these shallow pools. Shallow pools means they are not that deep. So in the presence of sun, there will be evaporation. So during evaporation, waters get evaporated and the remaining part is your salt. Okay, that's your salt. So now whatever you obtain from this process of evaporation, you get this salt which is very impure and have various salt mix in it. So basically this salt is purified and iodized. Basically we add some iodine. Why? Because it is very much important for the biological process, because in the lack of or the deficiency of iodine cause goiter. To avoid that, we add iodine before using. Now Number 2, which is from underground deposits. We can also found salt from the underground deposits. So the common salt is very impure and we call it rock salt. The rock salt, which is brown in color. Why brown? Because it is having impurities. You have to note it down. The rock salt is brown in color. Why? Because of the impurities present in it. Great. Yes. Now the uses of common salt. Common salt is very much useful. What can be the uses? You see, it is used in the manufacture of soap. Soap, the detergent, for the cleaning purpose we require them. So in order to prepare them, we require common salt. Preservation of pickle in curing the meat for a longer time and the fish. So basically in the earlier time, in India, there was tax imposed on Indians to produce salt. But the salt is very much important. Why? Because in the early time we were not having refrigerator. Refrigerator help us to store food for a longer time, right? It kills the production of bacteria. Yes or no? At the lower temperature. So at that time we were not having refrigerator. The alternate was to sprinkle some salt. If we sprinkle some salt in pickles or the meat or fishes, they decompose very slowly and we can place the food for a longer time. We can store the food for a longer time. So it is very much important. It has a very much important significance in the past and also right now. Now in order to make raw chemicals, right, in order to make chemicals, it is used as a raw material. What are these chemicals? Like the washing soda, the baking soda, your bleaching powder and whatnot. Okay, now melting of ice, that can be done by using or sprinkling salt over ice directly. So also in the cooking food we are using sodium chloride, the table salt. Now sodium hydroxide, which is also known as caustic soda. It is very much important for the cleaning purpose and very important for the opening of drainage, right? So basically what happens when the electricity is passed through an aqueous solution of sodium chloride, aqueous solution, which is known as brine, concentrated sodium chloride, it decomposed to form the sodium hydroxide. So basically the reaction seems like this. So we have the sodium chloride in aqueous and electricity is passed. Do you know when we pass the electricity through a solution and decomposition occur, what kind of reaction is it? Yes, of course, that the electrolytic decomposition reaction. So basically we are passing the electricity and converting or getting the product like caustic soda, Cl2 gas, which is green in color, and the hydrogen gas, which is explosive, as well as colorless gas. So how this reaction takes place? We call this reaction chlor-alkali. Chlor-alkali process. Why? Because in the product we see chlorine, which is known as chlor, abbreviated as chlor, alkali, the base, which is water soluble, alkali is NaOH, right? Hydrogen gas is a byproduct also. So we call it chlor-alkali process. The electrolysis of brine is known as chlor-alkali process. Why? Because it gives you the product as chlorine and alkali, like sodium hydroxide, caustic soda. So how this reaction occurs? So basically in this reaction we see there are 4 ions: Na positive, Cl negative, H positive, OH negative. Yes or no? When we dissolve NaCl brine in aqueous or water, so we will be having these 4 ions. Let me write it here. We have Na positive, Cl negative, H positive, OH negative. So in this apparatus, we are given with the electrodes. We have one anode. Anode is positively charged and the cathode is negatively charged, right? So what will happen when we pass the electricity? The ions get the I would like to say the salt NaCl, and water is going to get ionized. When you pass electricity, the salt and water is going to get ionized or going to get dissociated into the corresponding ions. Now you see positive negative attract, yes or no? So Na positive, H positive are going to be attracted by this cathode. Why? Because it is negatively charged electrode. On the other hand, if I see this Cl negative and OH negative are going to be attracted by anode. Why? Because it is positive. Yes, so there will be some reactions. I will let you know what are the reactions that are occurring at anode and cathode. So in chapter 1, I clearly told you redox reaction, that means oxidation and reduction. So on anode, okay, anode, there will be oxidation, and oxidation means loss of electrons. Yes or no? Do you recall this? Of course. If not, you can recall these smileys altogether. So at anode we are going to get oxidation. Oxidation itself means what? Loss of electron. So let me check what are the ions that are attracted towards the anodes. That is the Cl negative and OH negative. Forget for a time OH negative, we will be taking Cl negative. So this Cl negative will lose electron because chlorine already have gained electron and it is known as the chloride ion. Yes, so now the extra electron that is present towards chlorine, it will be returning it back or will be losing that electron, right? If I balance this, it can be written as this, 2 electrons. So at anode I can clearly see that these bubbles are of chlorine because the chlorine is depositing on this electrode. Why? Because there is loss of electron done by chloride ion, or it is depositing on anode. It is green in color, you can clearly see. What is next? Now I have cathode because I can see the anode. At anode, chlorine lost 2 electrons. Now these 2 electrons are going to be consumed by what? Let me check. Hydrogen or sodium? I will be taking hydrogen. So hydrogen will be taking these 2 electrons and will be converting into H2 gas. Yes or no? So on cathode, there will be liberation of hydrogen gas, accumulation of hydrogen gas. Yes, now see, listen carefully. Hydrogen has a very tragic story. Hydrogen have only 1 electron. Yes, in the case of H positive, there is 0 electrons. Yes or no? No existence, no electron. So what happens at cathode? There will be reduction. Reduction means gain of electron. This hydrogen is watching chlorine, that the chlorine is losing electrons. So why can't I get them? Right? So chlorine is losing that electron and hydrogen come up with the acceptance and get these electron and get converted into hydrogen gas. So here this is your process how it takes place. So hydrogen gas is collected on cathode. The chlorine gas is collected at anode. What about Na positive and OH negative? They have old friendship, right? Positive, negative. They get collected somewhere here, making NaOH, which is alkali. Right? Do you recall the name of this process? Chlor, because of the chlorine, production of chlorine. Alkali, because of the production of alkali, chlor-alkali process, right? So in this process we get chlorine. Now we can use this chlorine in the manufacture of bleaching powder and whatnot. So are we good with chlor-alkali process? Great, you can do it by your own. Now we are going to see the uses of the products. So at cathode we get hydrogen gas, at anode we get the chlorine gas, and in between we got NaOH with the caustic soda. So hydrogen is explosive gas. You see, it is used in the formation of ammonia. Ammonia is NH3. It is produced when N2 plus nitrogen plus hydrogen is reacted. It will be forming ammonia. And all the nitrogen containing compounds are very much useful in fertilizers. You see, ammonia for the fertilizers. What about chlorine? For water treatment. Have you ever went to the swimming pools? Of course. So basically these water treatments, in order to kill the bacteria, we add chlorine in the swimming pool, in the waterworks, also in order to make the polyvinyl chloride. What is that? The insulation on the wires, electrical wires, that is done by PVC, polyvinyl chloride. Chloride means chlorine is present. Disinfectant, CFS, and the pesticides. Now NaOH, which is your caustic soda, it is used for degreasing the metal. You know, metal got greased, so in order to clean that we use caustic soda. Soap, detergent, and the paper making artificial fibers, we are using caustic soda. All together, if I combine these two, H2 plus Cl2, it will be forming HCl, yes or no? So HCl can be used for cleaning steel, ammonia, right? Next we have ammonium chloride. Next, chlorine and NaOH, both all together form bleach, which is sodium hypochlorite. Bleach is used for the household bleaching, the fabric, etc. So these are very useful materials that we are getting as a product from the chlor-alkali process. So mind it, chlor-alkali process is one of the very important and the favorite topic of the examiner. Now moving further with the bleaching powder, in our syllabus we have calcium oxychloride, which is known as bleaching powder. So bleaching powder is produced by the action of chlorine. From where we are getting this chlorine? Of course, from chlor-alkali process. We got that chlorine, right? We treat it with calcium hydroxide and we get our desired product, which is calcium oxychloride, along with formation of water. Now bleaching powder represented as calcium oxychloride through the actual composition is quite complex, right? This is way deep. Now you see, how can we write this reaction? How can we recall this reaction for a longer time? Calcium has a valency of 2. Yes, so it will be forming 2 bonds. So I can write OH whole twice like this way. Yes, and there will be Cl2. Of course, when I can see this kind of scenario, I can remove water. In order to form water, I will be getting one OH from any of these bonds and one hydrogen. So it will be forming water. And whatever is remaining, you can write all together. CaO, Cl2. That is your calcium oxy. This oxygen is oxychloride. This is a white color of powder, you can see. So bleaching the wood, cloth, linen, etc. in the industries, we are using this bleaching powder. Also, it is a good oxidizing agent in the industry because it carries the oxygen. It can provide that oxygen. In the manufacture of chloroform, in the movies, you might have, all the time we imagine to get that magical solution that in the movies we see anybody a solution is mixed or the pour on the your handkerchief or something, and when you place this on the nose of somebody, the person gets fainted. So that is what we call chloroform, right? So in order to form the chloroform, we are using bleaching powder. What is next? So basically we are having the baking soda. Already we have discussed, it is basic in nature, so it is used as antacid to treat acidity in the stomach. So the baking soda is commonly used in the kitchen for many purposes. What can be the purpose? For making tasty crispy pakoras, in order to get the crispiness, okay, and sometime it is added for the faster cooking. Encircle the characteristics. Now the chemical name of the compound is sodium hydrogen carbonate or sodium bicarbonate. Sodium bicarbonate. So next is, it is produced in using sodium chloride as one of the raw material. We are getting it from sodium chloride. Of course we have already checked from where we are using the sodium bicarbonate, from where the sodium carbonate, the salt, is derived from. Now it seems like white in color, white powder. Okay, let's discuss more points about baking soda. So baking soda has many uses in our day-to-day life in order to make the baking powder. Have you ever wondered baking soda and baking powder are two different things? If not, let's understand this. Use of making powder. So baking powder is used in making baking the cake, right? Making it more fluffy. So basically baking powder is the mixture of baking soda, sodium bicarbonate, and the mild edible acid. So basically baking powder is the mixture of baking soda plus edible acid, which can be tartaric acid. Both together makes baking powder. You see, edible acid such as tartaric acid, when baking powder is heated or mixed with water, following reaction can happen. So basically you see, this is your baking powder. This H positive is coming from what? Acid, the edible acid. H positive ions. What is the existence of H positive ions? That means they are indicating there is presence of acid. So you see, CO2 and H2O and the sodium salt of the acid is produced. So basically this is what happens when we are making baking powder. So used as antacid because its nature is basic. Now used in the soda acid 5 extinction because it decompose and gives you CO2, which is not a supporter of combustion. Are we good? Now used while cooking. Of course it is a good cooking ingredient in the kitchen. Washing soda, used for the cleaning purpose. So cleaning is very much important. Hygiene is very much important. So we require what? Washing soda. Sodium carbonate is partially soluble in water, hence it is precipitated as solid. So have you seen the detergent? Yes, of course. So that is what sodium carbonate. It is filtered and dried, heated to obtain the sodium carbonate as. So basically, let me tell you how we are making the baking soda. First, we will be preparing the baking soda. The reaction. Okay. Baking soda is prepared by the Solvay process. Very important process. in this process, what we can do? We are having 4 ingredients. 1, 2, 3, 4. What are these? NaCl. We have NH3, number 2. Now we have CO2 and then water. It will be giving you NaHCO3. And the byproduct is NH4Cl, which is ammonium chloride. Very much important. Sometime examiner can ask you what is the byproduct of Solvay process when we are forming what? Sodium bicarbonate. So basically this is the process. Can we do that? Of course. Now we have seen this. This is your baking soda. So are we good with this reaction? Great. So now when I am talking about the washing soda, what can I do? I can heat this sodium bicarbonate. When I am going to heat it, it is going to convert into soda ash. There will be evolution of CO2 and water will be formed. It is also a white color powder. Your bleaching powder is somehow yellowish white color. Otherwise, all the salt are found in white color. Now, uses of washing soda, basically we have in the manufacture of borax. Borax is also a cleaning agent. Cleaning agent, that is Na2B4O7. Right, which is used in manufacture of detergent. As a cleaning agent, of course, it is used for cleaning agent degreasing. Now we have removed the permanent hardness of water. Permanent hardness, water can be hard. Water can be hard or soft. What that means? Hard when it does not form leather. Leather with soap. Have you ever experienced that? You are rubbing your hand in water with the soap and you are not getting the leather. That's the hard water. And then we have the soft water which is going to produce leather. Now this hardness can be further temporary or permanent. Right? So temporary hardness can be cured by boiling the water, while the permanent cannot be, rectified by boiling it. So basically, in order to get rid of permanent hardness, we use washing soda. Right? We have written this. Now, in glass and paper industry, we are also using it. Now, last but not the least, we are having plaster of Paris. We call it POP. Have you seen these uses of POP before? Of course. Now you see, if you are broken your bone, so in order to it gets dislocate, doctor apply POP in order to get the bone located back to the place. So you can see this. Now India has diversity. There are different functions. There are different culture. There is different festivals. So in order to form these items, we are using POP. Also for the decoration of ceiling, right? Your ceiling, that is also done by POP. Now you see, on heating gypsum is what? Gypsum is copper sulfate dihydrate, right? So that is your gypsum. When you heat this at 373 Kelvin temperature is important. It loses water molecule and becomes calcium sulfate hemihydrate. So if I heat this, it will be forming calcium sulfate hemihydrate. That means half water molecule and 3/2 water molecule will evaporate, will disappear. Are we good? So that's your POP. Now this reaction can also go back, right? These water molecule can get accommodated in the form of moisture by this calcium sulfate hemihydrate, and it can convert into the solid hard mass, which is your copper sulfate. Now you see, plaster of Paris Give me a moment. Plaster of Paris is a white powder. On mixing with water, it changes into gypsum, which is a hard solid mass. Now the reaction you see, the reverse reaction we can see. So we are making the gypsum back. What is this 2? This is water of crystallization. So what is water of crystallization? In 1 formula unit of any salt, the number of water molecule we are adding, that is your water of crystallization. So this is it about today's lecture. We have completed the whole chapter in one shot, which was very amazing. If you have any doubt related to these, you can definitely drop your doubts in the comment section. I will rectify it somehow. So let's meet in the next lecture. Till then, study hard. All the very best. All the very best. Thank you so much. God bless you all. See you next time.